What does this 19th century patent have to do with high-performance sports cars in the age of today? How does this dingy screw help keep Corvettes so cool? And how does force measurement, which essentially boils down to pressing on something super hard, tie all of this together? In this series so far, we've talked about metrology, the science and practice of hyper-accurate measuring that makes possible every modern tool from jet engines to MRIs to sonic toothbrushes. No, not every modern miracle is equal. And we've talked a ton of shit about how few people know what metrology even is, while it touches on nearly every aspect of how our era works. So this episode dives into how every aspect of every aspect we mean. When we last met, I was in Las Vegas. Now, we're headed to Florida. Owing to a few wrong turns, I found myself camping outside Devil's Tower, Wyoming, where I took these creepy pictures. Turned out to be climbers climbing down at the end of the day, but you spend 45 years seeing Devil's Tower like this, and you roll up for the first time in reality, and 5 minutes after you get there, you see this before a massive storm moves in. It has an effect. This was apropos of not much, but it didn't naturally fit into any other episode, and I will be damned if it's left on the cutting room floor. Anyway, point is, eventually I made it down to Clearwater, Florida, where I met Dan Dorset, the owner of Van Steel, maker of aftermarket Corvette parts. When I confirmed I'd be visiting Florida in August, Dan emailed me, "You're going to love Florida in August. LOL. I soon discovered just how sarcastic his LOLs could be.
Why Corvettes? Why are Corvettes the coolest car on earth?
For me, just growing up around it since I was a kid, my dad, he started as a body shop in New Jersey working on Corvettes. He always just liked the Corvette the best. And then when he bought the business, it was just always Corvette, Corvette, Corvette. It's probably the best affordable car that you can buy. That's you can just jump in and go to a racetrack and have a blast without having like Ferrari money.
That's right. Working class Americana Moxie poured onto 4 good years. So much so, Chevrolet gave away Corvettes to the NASA astronaut corps back in the 1960s.
Do any astronauts actually use your parts on whatever Corvettes they might have?
I don't know if any astronauts use our parts or not, but I do know that they did get Corvettes back in the day.
Do they still get Corvettes or do they not get Corvettes?
I don't know if the astronauts still get Corvettes or not. It was a good marketing scheme though.
In fact, Chevrolet does not currently give astronauts free Corvettes. According to NASA, there are 38 members of the active astronaut corps. At an MSRP of $65,000, that's $2.47 million to outfit them all. So, for the cost of just 1/3 of one Super Bowl ad, Chevy, you can provide these deserving American heroes truly bitching rides. When I was done teasing Chevrolet, Dan clearly wanted no part of my shenanigans. We started talking about Van Steel's metrology problems.
So the life cycle of suspension parts, or any part from a manufacturer's perspective like General Motors or Ford, is they have a 10-year obligation to build parts for warranty or replacement stuff, and then it goes to the aftermarket after that. One of the things that we manufacture is composite springs. The composite springs, what they do is they basically hold the car up. The way that the Corvette is since they are independent suspension front and rear, the composite spring just packages very well.
What makes composite springs better?
The spring is probably 30 pounds lighter than a steel spring. It doesn't lose its spring rate, and they seem to ride better. They're smoother. There's no stiction between the plies of a leaf spring. So you just a better all performance. Plus we can adjust spring rate for different applications. So if a guy wants a cruiser, he wants a nice soft ride, we give him a softer spring. If someone's more performance oriented, we give them a stiffer spring.
So we come to it. The reason an auto parts shop focusing on one model of one automaker's whole line needs metrology to survive. For Van Steel to sell springs, Dan needs to know just how springy his springs spring.
So what's the problem that metrology solves for you? Why is it so important that you measure these springs to this level?
It's because they all have different arches. So if we make a spring that is too stiff and an arch that is too tall, the car will not get to ride height. And then you get the phone call, hey, my car won't sit down, what can we do?
This is the machine in question. It presses down on the springs they produce as one of the last steps in their production process. And when Dan took over the business from his dad, he had a problem. The machine they used back then to measure their springs, a force measurement system that used hydraulic pressure to work, it wasn't that great.
So when we were doing it hydraulically, the number would change every time you put load on the spring to get the spring rate. The reason why the machine is so important to us and how we measure it is for spring rate. So like for the C2, C3 cars, we have like a 300 spring rate, a 330, 360, and 400. Basically, when we acquired all of this equipment for the composite springs on how to measure it, that machine is probably 40 years old. Everything was being measured out through hydraulics, and it just wasn't accurate enough. So
back in the day, it would be like 300, 310, 37, 315,
Correct.
and you would be like, I don't know what the actual...
Correct.
So you would have a hard time telling your customer, hey, this is what this spring is gonna do.
Correct.
My entire business's reputation rests on what the spring can do, but I have to tell you,
I don't know what the rate is.
I don't know what the story is.
To make all this clear and easy to understand, Dan took me on a little tour of his shop where he and his crew make their springs. But first, he laid out why one measurement was at the core of his business.
So Corvette goes by generations. You have your first generation, which would be C1, then it goes C2, 3, C4, C5, C6, C7. I don't have a picture of the C8 on here yet, but...
Correct me if I'm wrong, it is important professionally for you to know the Corvette inside and out.
Yes. Suspension-wise anyway. I don't know about like a lot of the interior features that some years have or some years don't.
Fair enough, but you know, professionally, for your job, you need a Corvette. So you can buy a Corvette and write it off on your taxes.
Yep. Yes, sir.
Some people have all the luck.
Yeah.
Enter this man, Eric Perkins, a product specialist for the Force Measurement Division at Starrett, one of the world's leading metrology equipment companies. Remember how I said a part of this story goes back to the 19th century? Well, let's step back to the 1800s for a second. This is Athol, Massachusetts, and this is Leroy S. Starrett. While Leroy was born in the 1830s in a town confusingly named China, Maine, it was when he moved to Athol that he invented this, the automatic meat chopping machine of 1865. It chopped everything. It made Leroy famous and was widely celebrated, as you can see here. He was the Steve Jobs of chopping things. I would love for there to be some dramatic story with twists and shocking reveals, but Leroy Starrett just liked inventing things. He was good at it. So eventually, he turned his talents to making tools. Like his automatic meat cutters, they were celebrated too. He's the one who invented the world's first combination square, a backbone of wood, metal, and masonry construction that's remained largely unchanged from the era of the Transcontinental Railroad to the era of translunar orbits. Success built on success, and now Starrett is famous around the world for tools, measuring equipment, and meat cutting blades. In fact, cutting blades of all kinds. These are steel cutting blades at their booth at the International Manufacturing and Technology Show a few years ago in Chicago. Starrett is to saw blades what Apple is to computers. So, pretty good. It's nice to see Starrett hasn't forgotten their roots. Anyway, back to Florida. Now, given Eric works for Starrett, he is the best person to explain the hows and whys of measuring Dan's springs.
What is force measurement?
It's the ability to put a number against a weight or pushing against something or lifting something. So it's a way to put a number to it.
So what this machine does is it pushes really hard on these springs, figures out how
much load it was based on the load cell. So the load cell is the sensing device, so it actually measures the load, but it also, we have a rotary encoder in there that tells you how far it actually moved.
What's a rotary encoder?
So it's a very accurate device that measures stuff down in the micron level. So it's looking at pulses of light, and as it changes, the motor moves the ball screw moves the encoder, you get these little light pulses, and it's counting the pulses to measure how far it actually moved. So this is one of our force measurement systems. It's an FMS 5000. So it does both tension and compression or cycling. In this configuration is not normal, but to make their fixture work, we were able to reconfigure a standard piece of equipment to do the task that they're trying to do here. And that's in replacing the old hydraulic system with the electromechanical device.
See, the idea is this big screw moves up and down. It measures how much it goes up and down and how much force it takes to move it up and down.
How fast, and how much.
So basically all of metrology boils down to how big is this and how much did it move?
And where did it break?
To quote the great Bill Murray,
Type something, will you? We're paying for this stuff.
or in our case, let's measure something.
After the spring is in the load cell, we shut the cage before we run the program.
That's for safety, in case any of the springs decide to fail spectacularly and fling their parts all across the shop. Although Dan assures me it's only happened once. Safety first.
So when it pops off, does it make a giant boing sound?
To test, they turn the screw on the load cell, which presses a weight force on the suspension spring. They do this 5 times and take the average of those runs to decide the rating. So here we're seeing the run show this spring is rated at 414. You can see that right here. So after that, it's packed up, shipped off to an expectant Corvette owner, and soon more rubber is being burned to the hot rod gods. So that's the story of how a 19th century New England meat shopping inventor ended up creating some of the best metrology equipment that now measures the springs on one of the coolest 21st century sports cars. It is nuts, the forgotten history that surrounds us. In this case, a single part, one of 12,000 or so, on a sports car. Anyway, since we're on the subject of astronauts, we may as well go all the way to the moon. Or maybe we'll visit the Wizard of Oz, the future of filmmaking and architecture, and also how the Allies won World War II. It all depends on NASA's launch schedule, so no pressure, NASA. We know you got a lot on your hands, but we have got a YouTube schedule to keep, so, you know. With that, I'll see you down the road.